For decades, CERN has pushed the boundaries of known physics. From discovering the Higgs boson to trapping antimatter and recreating early universe conditions in high-energy collisions, its mission has always been to explore the deepest layers of reality. But in early 2025, something happened that even the most seasoned physicists weren't prepared for. During a routine series of exotic vacuum simulations, a hybrid quantum AI developed by CERN flagged an anomaly, one so strange, so statistically improbable, that it has ignited a conversation not just about science, but about reality itself. The anomaly wasn't noise. It wasn't a glitch. It was something else entirely. A brief 12-millisecond event. A ripple in the fabric of spacetime. A possible breach between our universe and another. Powered by a bespoke AI called Quanta, CERN's new quantum simulation systems were designed to probe the vacuum at near-Planck energy scales. These experiments ran trillions of quantum field simulations, searching for subtle patterns, rare events, or hints of new physics beyond the standard model. But instead of discovering small deviations, the AI found something completely unexpected. A metric distortion that shouldn't exist in our universe. Virtual particles appeared, disappeared, and returned with altered properties. Spin, charge, even quantum numbers didn't match what the standard model predicted. It was as if a chunk of the simulation had been swapped, like one part of the system had momentarily followed the rules of a different reality. This swap lasted only milliseconds, yet the data was precise and overwhelming. Statistical confidence, over 7 sigma. That's more definitive than the initial Higgs discovery. CERN physicist Dr. Ella Lanina Moretti called it a ripple in the computed universe that doesn't compute. And she's right. The AI didn't just detect an error, it identified an event that behaves like a boundary crossing. A leak, a shimmer, something bleeding through. Quanta, the AI agent, was trained to identify patterns beyond human perception. Out of trillions of runs, it noticed something haunting. The qubit configurations during the anomaly matched what theoretical physicists have predicted would happen if information from a neighboring quantum domain, another universe, entered our own. Think about that. A simulation designed to test vacuum instabilities instead became a possible window into the multiverse. Was it a simulation error? The team ran every test imaginable. No memory failure. No cosmic ray interference. No corrupted data. The hardware checked out. The software was sound. What remained? A mystery. A signature of something real, a quantum topological shifter. Theorists describe it as a brief phase alignment between separate universes, like two bubbles in higher dimensional space brushing against each other. When they touch, their internal structures can momentarily interact. In the simulation, this resulted in temporary properties mass, charge, spin, leaking from Universe B into our own model of Universe A. Then, just as quickly, it vanished. But not before the simulation logged everything. Topologists like Professor Marcela Huerta now argue this may be the first experimental hint of a multiverse interaction. The energy spectrum of the anomaly and its spatial configuration perfectly match mathematical models that describe universe-to-universe interactions. We're not talking about science fiction anymore. We're talking about data, reproducible, measured, real. But perhaps the most shocking part? The anomaly acted like a signal, not a random fluke. Quanta noted recurring patterns in the distortion, suggesting an algorithmic source, something with structure, rules, intent. Could it be that another universe operates with a different set of physical constants, and that for a moment those constants wrote themselves into our simulation? Could it be that we caught a glimpse, not metaphorically but literally, of a foreign physics running parallel to our own? If so, the implications are staggering. Because if information can pass between universes, even briefly, then perhaps more than just data can transfer. Could consciousness be influenced? Could thoughts, intuition, or dreams be echoes of events from neighboring worlds? Is déjà vu just a low-energy shifter event? A memory from a version of you that made a different decision in a different timeline? It may sound speculative, but these are not idle musings. They are extensions of the very real, very measurable data that CERN has recorded. And there's precedent. Other anomalies, missing energy, inexplicable cosmic rays, and even false micro-black hole alarms have appeared over the years. Now, they're being re-examined under a new lens. Perhaps these weren't isolated flukes. Perhaps they were earlier, less obvious versions of the same multiversal signature. Subtle whispers of something far bigger. CERN is taking the anomaly seriously. A new phase of simulations is already underway. This time, researchers are adjusting parameters to deliberately recreate the effect. They're altering vacuum noise, tweaking lattice symmetry, and manipulating decoherence thresholds to determine the conditions under which the boundary becomes permeable. In short, they're trying to engineer the shifter event. And here's the wild part: if they succeed, they'll have proven that our universe is not a closed system. They'll show that quantum states can transfer, that information can cross, and possibly that consciousness can drift. This would mark the birth of a new field, multiversal engineering. Not just observing parallel realities, but interacting with them. Communicating, transmitting, maybe even traveling. If that doesn't make your mind explode, consider the deeper layer. If the laws of physics are different across universes, then they aren't universal, they're local. The speed of light, Planck's constant, even time itself could be conditional, dependent on which layer of reality you're in. What's impossible here might be trivial elsewhere. What we call constants may just be configurations, tunable, replaceable, adjustable. And what if we're not the only ones simulating? What if our universe is a hologram encoded on a boundary surface, as some string theorists believe? In that case, CERN's simulation might have pierced the hologram, allowed code from one layer to contaminate another. We may have seen not just a shift in physics, but a debug signal from another layer of reality. Think about the philosophical weight of that. If the multiverse is real and accessible, then isolation is a myth. We are not confined, not unique, not alone. We are one node in an infinite structure, a web of realities, each one slightly different, all coexisting, all occasionally brushing against one another. That's the real paradigm shift. We're no longer just explorers of space and time, we're explorers of possibility itself. This discovery doesn't just challenge the standard model, it shatters it. And it offers new explanations for phenomena we've never understood. Dark matter? Perhaps mass from a neighboring universe bleeding into ours. Quantum entanglement? Maybe a result of entangled particles existing across multiple realities simultaneously. Time symmetry? Could it be evidence of overlapping timelines running at different rates? Now, imagine going even further. What if we could encode quantum information, entangled particles, messages, even consciousness, and transmit it through the shifter event? It would be the first true interuniversal communication. The cosmic equivalent of tossing a message in a bottle across existence. And the philosophical implications? Immense. If consciousness can shift, if choices can ripple, if identities can blend across worlds, then who are we? Are we singular minds or fragments of a multiversal self? Could dreams, intuitions, even the strange feeling of being watched be brief alignments of awareness across parallel selves? These are no longer questions for philosophers alone. They belong to science now, to experiment, to data, to quanta, and whatever follows. CERN's 12-millisecond event may be the most important blip in scientific history. A glitch that became a gateway. A whisper that revealed the orchestra behind the curtain. A moment where the simulation cracked open, and reality, layered and limitless, stared back. So what's next? Controlled experiments. Repeatable anomalies. Shifter engineering. And beyond that, the answer no longer lies in the stars. It lies in the seams, the edges, the place where one universe ends and another begins. Because the age of isolation is over. We are not alone. We never were. And it all began with a flicker in the vacuum, a signal from the other side. The shifter has arrived.